We're at ADLINK here, and I'm talking with Jeff. And Jeff, I know you guys from the ATCA world, but maybe you could tell us a little bit about your role in telecom in general. Does it go beyond that?
Wow, ATC world, that's old technology
That's
now.
old school, yeah.
As you know, ADLINK has been in the embedded space for a really long time. And actually, we've expanded a lot of our programs into more platform-oriented businesses. ATCA was a start,
Okay.
but we're also doing key platforms for NFV and SDN, appliance-based platforms that are all considered next-gen from ATCA. As you know, the telecom environment, the networking world needs the next generation of backplane technologies, new silicon technologies, mainly for infrastructure around clouds. Both from a data center and also from an edge.
How different is the cloud, are the cloud requirements? When you talk about things like backplanes, those kinds of things, is the cloud much different from what we think of as a regular network?
So if you think of how ATCA over the generations, you went from a 10 gig backplane to a 40 gig. Now there's 100 gig, now there's 400 gig. Now there's a lot of different capabilities that are being required, mainly driven by applications that are running into a virtualized manner, such as security-based programs that need lots of horsepower, lots of speed, because these are considered bump in the wire. So if you have all of these different routing capabilities and security capabilities all throughout that whole chain of applications, it's going to slow it down. So the technology has to be about speed, it has to be around feed, and it has to be about usability.
I've seen you guys are doing work with the Open Compute Project, which seems like a pretty natural fit. Can you talk a little bit about what you're doing there?
We joined about a year and a half ago, really focused on the carrier grade capabilities of OCP. So if you think of OCP from a data center environment that was really driven by the Facebooks, the Googles, Bank of Americas, the operators, the service providers are looking at that type of infrastructure and saying this is great because it's an open architecture, number one, so it enables multiple vendors to play in that space. It's a data center environment that has a tremendous amount of silicon capabilities. It has the speeds and feeds, as I mentioned, that they require. And it also has a common infrastructure that they can wheel in an entire frame that would be compatible to the other pieces that within their network, just like the data centers are migrating to today. So the reason that we joined is ADLINK is a true believer in open architecture. So we realize that the proprietary nature of hardware is kind of becoming the thing of the past. So ATCA was a good stepping stone, and with ATCA, COTS-based hardware, multiple vendors that are playing into that space, kind of created that great environment. But ATCA really didn't take off like we think OCP will, because now with OCP, it's taking an environment that's already proven and putting it into the central offices at the edge.
Okay. One thing that struck me about OCP is that it does kind of straddle the data center and telecom worlds, and there does seem to be more overlap between what's in a telecom network, what's in a cloud network, what an enterprise network looks like. Are you seeing these lines blurring a little bit?
We are definitely seeing a convergence of all these networks.
Okay.
And if you look at it from a service provider's perspective, they're trying to do two major things. One is to optimize their networks, to get into a mode of operation which is much easier for them to deploy new services, and also to manage their network. And that's just some of the key low-level assets of NFV and SDN. They don't want to just be a pipe. They want to actually add services to all their customer base. And by doing that NFV and SDN architecture using OCP gives them that type of form factor because it's all open architecture. I can buy a sled from vendor A or vendor B and it'll fit into this shelf perfectly. Especially with OCP because it's getting into the data centers, now it's getting into the central offices. Although the architecture is a little bit differently, but the sleds themselves, you know, they're going to be considered OCP generic or OCP accepted that they'll be able to fit in each individual device. It's that frame infrastructure that's a little bit different.
You know, looking at NFV, it's a carrier construct, right? The carriers came up with the whole concept, but is that the kind of thing that could be applied in other kinds of networks? Does it have a place anywhere else?
NFV, if we look at NFV today, if we take a snapshot, we're primarily into proof of concept and trials.
Okay, yeah.
Ensuring, because we are talking about public networks here, so we want to make sure everything is working, not just within an internal network, but between networks.
Okay, fine, sure. We can do that.
We want to have there's no such thing as Dalton anymore. We want to make sure we can text my friend.
Right.
So with an NFV, once that NFV infrastructure is up and running, we see other industries saying this is a great environment. This this LTE network or this upcoming 5G network kind of fits our space from a private world or an enterprise world better.
Okay.
So why do I want to recreate the wheel and create an infrastructure that's already proven in the industry? And oh, by the way, it's an open architecture, both from a hardware and software that's standards-based and I can implement in my enterprise space.
So when you look at other industries that might want to use NFV or that might be interested in the architecture, who do you have in mind?
Yeah, banking, healthcare could be one, but what we are starting to see a big migration on improved technology, especially in communications, is the military. Not just the U.S. military, but global military in general.
Okay.
And if you think of what they term command and control, basically that's communications, is having the ability for troops, machines, all talking together. It sounds a lot like what our telephone networks are. So it's hardened, it's private within that network, I can't break into the network elements, and they like that. And not to mention, it's off-the-shelf hardware. So it's proven technology, lots of vendors out there that play in that space, both from a hardware and software perspective. And it has the speeds and feeds that they really need to transport video, data, and voice, especially in warfare or in non-warfare areas. So private LTE networks are a big focus on not just the U.S., but other markets as well, looking at what the operators have done, what the standards have done, and what the vendors have done, and testing it within a militarized environment.
Well, that makes sense because then they can use. They have the need for spontaneous networks, spontaneously generated networks out of nothing, and if they can do it with COTS hardware, so much the better, right?
Oh, absolutely. And the cool thing about it is with the virtualized technology that we have, you can put an entire EPC network on a small circuit board and a backpack.
Okay, the evolved packet core.
Exactly, the evolved packet core.
Into a backpack, okay.
Into a backpack with, instead of having a small cell, it's in a drone flying over. So the technology's there, and it's of great interest. And then as we move into more and more virtualized assets, then you're getting into media, video transmission.
Right. Yeah.
You're getting in additional services that their operators are looking at that the military can use as well. And now our friends in the service are using smartphones versus this big walkie-talkie or whatever. So great value that we're seeing from cross-pollination between all of these different technologies.
Oh, great. You have to admit the big walkie-talkie is cool.
It is cool. It is absolutely cool.
So light reading, obviously we care about the Internet of Things, right? It's the big topic. And I would imagine you guys have a role to play in MEC, in the mobile edge computing, or I guess it's now called multi-access edge computing. What have you got going on there?
So we've been part of the MEC ETSI Standards Committee for a while now. We're co-sponsoring with key companies like Intel. Saguna is another great company, software company that we've partnered with that offers MEC middleware attributes. And we really see the edge as the key benefit of the transitioning into 5G networks. So if you think of really the low-level attributes of 5G, it's really about I want it faster. I want these big pipes now coming to my device. And I'm also adding more and more devices to my network, IoT-based devices or smartphones, smart devices to manage everything known to mankind. So with that, you can't do all that in a cloud.
Right.
Mainly,
Everything has to be distributed, right? The smarts have to go everywhere now. Right?
Exactly. Edge computing, to us, and I think a lot of our partners as well, is critical to that 5G transition because now your latency is lower, you've got more horsepower at the edge. And by the way, we define edge as anything that's outside the data center. So that could be the central office,
So
that could be...
That's the whole world in a sense.
Exactly,
Yeah.
exactly. So it could be the radio tower, it could be the small cell, it could be customer premise, whether it's a residential home or it's a office building. That is what we kind of consider the edge. And what we've done, working with the Etsy groups and our partners and us as a manufacturing, we've created reusable components and reusable platforms that can meet all the way from customer premise to the central office. And with OCP, now even into the data center with hyper-converged infrastructure.
Interesting. So you have one platform that, if I heard you say this, if I heard you right, you have one platform that fits the data center, but also the edge, meaning the rest of the world that that isn't the data center. It's basically a universal thing.
Exactly. But we also realize, in the space of edge computing, that a lot of the applications that are going to be fitting on these edge devices are fairly niche-based products, security-based products, firewall products, these things that need very low latency, high compute power, lots of I/O. And with all of these plug-and-play modules that we have going from again, the customer premise to the data center, and enables all of these different applications on a common set of hardware. We offer outdoor servers, so you're basically putting a data center at your radio tower, which is pretty awesome.
Great. Well, great talking with you, Jeff. Thanks for your time.
Thank you.